We look up at the night sky, a canvas of diamond dust scattered across velvet black. It has been humanity's constant, a symbol of eternity, a silent, unchanging witness to our fleeting existence. But this perception of cosmic stillness is a profound illusion, a tranquil veneer masking an unimaginable slow-motion catastrophe already set into motion. For billions of years, our majestic spiral home, the Milky Way, has spun in relative isolation, a vibrant island in the vast ocean of the cosmos. Yet, its tranquility is finite. On the cosmic horizon, a titanic stormfront gathers, a galactic behemoth twice our size, its gravitational tendrils already beginning to brush against our outer edges. Its name is Andromeda, and it is hurtling towards us at an astonishing 250,000 miles per hour. This isn't some abstract cosmic dance unfolding in a distant, forgotten corner of the universe. This is our future. Our sun, our Earth, our entire solar system is on an unavoidable, irreversible collision course with this monstrous neighbour. The serene tableau above our heads is destined to be ripped apart, then painstakingly reassembled. The stakes are nothing less than the destruction of our cosmic home as we know it. Our familiar constellations will be erased. The stable orbit of our sun, a constant for nearly 5 billion years, will be cast into gravitational chaos. Our blue planet, once nestled in the perfect life-giving zone, faces a slow, certain demise, either flung into the icy intergalactic void or scorched by a sun in disarray. In this documentary, we will chart the meticulous science behind this inevitable cosmic apocalypse. We will explore the subtle gravitational precursors, the dramatic restructuring of galaxies, and the terrifying existential implications for our solar system and the fate of Earth. Join us as we journey into the distant future to witness the slow, yet unstoppable, destruction of our galactic home. Like and subscribe to Terran, and prepare to confront the ultimate cosmic displacement. Prepare yourselves, we begin. Our cosmic narrative begins not with a bang, but with a whisper echoing across 2.5 million light-years of intergalactic space. It is the gravitational summons, an irresistible force drawing together the two titans of our local group, the Milky Way and the Andromeda Galaxy. This isn't a theoretical possibility, or a distant astronomical curiosity. It is a calculated certainty, a celestial appointment set billions of years ago by the very fabric of space-time. The collision, affectionately dubbed Milkomeda or Milkdromeda by some astronomers, is not merely looming. It is already underway, a slow-motion cosmic ballet that will forever redefine our galactic home. To truly grasp the monumental scale of this impending event, we must first confront the sheer distances involved. Andromeda, formerly known as Messier 31, currently holds the title of our nearest large galactic neighbour. Envision a colossal city of stars, a majestic spiral comparable to our own, yet even grander, boasting a staggering trillion suns strong, stretched across an immense expanse of over 220,000 light-years. This behemoth currently resides approximately 2.5 million light-years away from our solar system. To attempt to put that into a human-comprehensible perspective, if our entire Milky Way galaxy were shrunk down to the size of a dinner plate, Andromeda would be another dinner plate positioned just a few feet away. In the grand, largely empty cosmos, this is an uncomfortably close proximity, a cosmic dance partner already within arm's reach on the universal ballroom floor. But mere distance tells only half the story, and arguably, the less terrifying half. The true harbinger of our galactic doom lies in Andromeda's relentless velocity. This colossal spiral is not merely drifting passively through space, it is hurtling directly towards us at an astounding speed of roughly 110 kilometers per second, which translates to an approximate 250,000 miles per hour. To frame this incomprehensible speed, in the time it takes you to simply read this very sentence, Andromeda has already shaved thousands of miles off the distance separating our two galaxies. This relentless, unyielding approach paints the vivid picture of an unstoppable cosmic bullet, fired billions of years ago, now aimed squarely at the heart of our Milky Way. There is no force known to physics that can divert its course. How do astronomers arrive at such definitive conclusions about an event so unimaginably far in the future, involving objects so impossibly vast and seemingly immutable? The answer lies in the subtle yet unambiguous language of light itself, a cosmic messenger that carries tales of motion across the void. When light from a distant celestial object reaches our telescopes, its wavelength can betray crucial information about that object's movement relative to our own. This fundamental principle is known as the Doppler effect, a phenomenon we commonly experience with sound waves, the familiar changing pitch of an ambulance siren as it rapidly approaches, passes, and then recedes. For light, this shift manifests as a change in colour. In the pivotal case of Andromeda, its emitted light exhibits a distinct blue shift. This means that the wavelengths of light reaching us from Andromeda are measurably compressed, shifted ever so slightly towards the bluer end of the electromagnetic spectrum. This blue shift is the undeniable spectroscopic signature of an object unequivocally moving towards an observer. It is the cosmic equivalent of an oncoming train's horn growing sharper and louder, confirming with absolute certainty that Andromeda is indeed on a direct, accelerating trajectory towards the Milky Way. This radial velocity, the speed at which it's moving towards or away from us, is the primary gravitational engine driving the impending collision. It is the first stark piece of evidence for our ultimate fate. For many decades, the compelling evidence of Andromeda's radial velocity provided astronomers with a strong indication of an eventual encounter. However, a crucial lingering uncertainty persisted. Was this destined to be a catastrophic, direct head-on collision, or merely a less impactful glancing blow that might spare our solar system the worst of the chaos? This critical piece of the cosmic puzzle required a different, even more precise measurement: Andromeda's proper motion. Proper motion refers to a celestial object's tangential or sideways movement across the vast expanse of the sky, perpendicular to our line of sight. Imagine attempting to predict if a car approaching you on a highway will hit you. You know its speed directly towards you, radial velocity. But to predict a collision, you also desperately need to know if it's drifting left or right, proper motion, into your lane. Observing such minute angular shifts for a galaxy situated 2.5 million light-years away is an astronomical feat demanding incredible precision and patience. It was the unblinking, keen eye of the venerable Hubble Space Telescope that finally settled this profound debate in 2012. Over a painstaking period of several years, Hubble meticulously tracked the positions of specific individual stars within the Andromeda Galaxy itself. By comparing their observed locations over time, scientists were able to measure Andromeda's incredibly subtle tangential motion. The findings were stark, unambiguous, and ultimately terrifying. Andromeda's sideways velocity is infinitesimally small, practically negligible, when compared to its dominant, head-on approach velocity. This observational triumph definitively confirmed that the two galaxies are not destined for a graceful near miss, nor even a glancing embrace, but for a truly monumental direct impact. The universe, in its grand, indifferent design, has set our home on an unstoppable path towards a gravitational embrace that will utterly, fundamentally transform it. This scientific confirmation, meticulously built upon decades of pioneering observation, advanced astrophysical modelling, and the relentless pursuit of precision, removes any lingering doubt. The collision is not a speculative theory, a mere hypothesis to be debated in academic circles. It is a future etched into the cosmic calendar with indelible certainty. The immense, overwhelming gravitational pull of Andromeda's staggering mass, combined with its high, accelerating approach velocity, ensures that the two galaxies are now irrevocably locked into an unavoidable fate. Even the general expansion of the universe, which typically drives galaxies apart over vast cosmic scales, is utterly insufficient to overcome the localized, overwhelming gravitational dominance of these two galactic giants. At this scale, in our immediate cosmic neighborhood, gravity reigns supreme, dictating a future of profound, terrifying, and inescapable change. The sheer scale of this inevitability is a concept almost impossible for the human mind to fully grasp. We speak casually in terms of billions of years, a timescale so unbelievably vast that it dwarfs the entire recorded history of human civilization, the rise and fall of countless empires, the slow, arduous evolution of every species that has ever graced Earth. Our Sun, the very source of all life on our planet, in its current stable, life-giving state, has approximately 5 billion years remaining before it begins its own dramatic transformation into a bloated red giant. The galactic collision, this ultimate cosmic reckoning, is set to commence in approximately 4.5 billion years. This critical overlap means that the initial gravitational dance, the first violent ripples of the merger, will begin before our own star consumes its hydrogen fuel and starts its final death throes. This is not an abstract event for some distant, far-flung descendants to potentially witness from a safe, newly colonized galaxy. This is an event that will unfold while our sun is still shining brightly, while Earth could, in theory, still harbour intelligent life. This chilling proximity in cosmic time to our sun's own life cycle only amplifies the existential dread. Our current stable existence within the Milky Way feels eternal, an unshakable foundation for our civilizations and dreams. Yet, it is merely a fleeting, tranquil moment in the universe's endlessly dynamic, often violent, grand narrative. The inexorable march of Andromeda, a silent, unseen force for eons, is not only accelerating but is now close enough for its gravitational shadow to lengthen over our galaxy. The initial ripples of this cosmic tsunami are already propagated through the vast, invisible dark matter, halos that envelop both galaxies, binding our fate to Andromeda's in an unbreakable, gravitational pact. Consider the profound journey of light itself from Andromeda. The individual photons that left Andromeda 2.5 million years ago are only now reaching the primary mirrors of our most powerful telescopes. They carry the ancient images of a galaxy as it was when early hominids first took their uncertain steps across the plains of Earth. In a future equally distant, photons that leave the nascent, chaotic and utterly transformed Milkomeda will carry the image of our new, merged galaxy to other hypothetical cosmic observers billions of years from now. This colossal journey of the light, spanning such immense gulfs of time and space, underscores the deep time involved and the long, slow, unavoidable lead-up to this momentous event. The approach of Andromeda is not a sudden, unpredictable cataclysm, but a cosmic ballet choreographed with ruthless precision over billions of years, now reaching its dramatic, inescapable crescendo. It is a slow, but certain destruction of our home as we've always known it. This long, drawn-out process means that the ultimate destruction and reformation of our current galactic home will not be an instantaneous, merciful event. Instead, it will be a slow, agonizing transformation, a drawn-out cosmic apocalypse that will unfold over hundreds of millions of years. The initial gravitational encounters will be like brushes, then a series of violent gravitational slingshots, pulling and tearing at the very fabric of both galaxies, before the final, full and irreversible merger. This is not a quick death for our galaxy, but a prolonged, inevitable reshaping, a complete, unceremonious erasure of the familiar stellar landscape. Our comfortable, stable position within the serene spiral arms of the Milky Way is merely a temporary reprieve before the overwhelming forces of galactic gravity take hold and begin to unravel everything we know, everything we call home. The unstoppable cosmic bullet is already here. The relentless approach of Andromeda is not a sudden, dramatic lunge, but a gradual, inexorable drawing together orchestrated by forces far more pervasive than the glittering starlight we perceive. Before a single star from one galaxy can ever truly see a star from the other, the true titans of this cosmic encounter have already begun their silent gravitational dialogue. We speak, of course, of the galactic halos, those immense invisible envelopes of dark matter that vastly overshadow the luminous disks of stars we call home. This is where first contact truly occurs, not with a visible crash, but with gravitational whispers that began echoing across the intergalactic void billions of years ago. Our understanding of galaxies has evolved dramatically. We once thought of them primarily as vast collections of stars, gas and dust. But modern cosmology, anchored by decades of observational evidence from galactic rotation curves to gravitational lensing, reveals a far more encompassing reality. Every visible galaxy, including our Milky Way and the colossal Andromeda, is merely a luminous jewel embedded within a far larger spherical halo of enigmatic dark matter. This invisible substance, which interacts with ordinary matter only through gravity, constitutes roughly 85% of the universe's total matter. It is these gargantuan, diffuse halos, not the star-studded disks, that are the true gravitational engines of galaxies, and thus the primary players in their cosmic dance. Imagine our Milky Way's visible disk, spanning perhaps 100,000 light-years, as a thin, delicate film of soap. Now, envision its dark matter halo as an enormous, almost perfectly spherical cloud, extending outwards for at least 500,000 to 700,000 light-years, perhaps even 1,000,000. Andromeda's halo is even grander, a massive diffuse sphere of gravitational influence stretching potentially twice as far. These colossal, ethereal structures are the true battlegrounds, the first points of contact in this cosmic confrontation. Long before the dazzling spiral arms of our galaxies are close enough to exert direct disruptive tidal forces on each other's star systems, their sprawling dark matter halos are already interpenetrating, feeling the profound, all-encompassing pull of the other's unseen mass. This initial gravitational embrace, occurring hundreds of thousands of light-years beyond our Sun's current position, is a subtle, yet utterly powerful interaction. It is a slow-motion dance of colossal invisible entities. The outer reaches of the Milky Way's dark matter halo are now experiencing the nascent tug of Andromeda's equivalent, and vice versa. This isn't a violent tearing at this stage, but rather a gentle, inexorable acceleration, a gradual steering of the entire galactic system towards its ultimate combined destiny. It's akin to two distant, massive ships feeling the distant pressure waves of each other's passage long before they're visible on the horizon, their courses subtly, but irrevocably, altered. The sheer scale of these dark matter halos means that the gravitational fields of the two galaxies are now overlapping significantly. This intermingling of gravitational influences creates the earliest, almost imperceptible perturbations. For stars, gas clouds, and even smaller dwarf galaxies currently orbiting the Milky Way at its extreme periphery, the distant looming presence of Andromeda's dark matter halo is already making its presence felt. These outer celestial bodies are beginning to experience a subtle, additional gravitational pull, a fractional shift in the forces that dictate their orbits. Over millions of years, these tiny cumulative changes will translate into significant deviations, acting as the vanguard of the more catastrophic events to come. This initial, unseen contact serves as a chilling foreshadowing of the grander chaos. The delicate balance of forces maintaining the Milky Way's outer structure is slowly being eroded, destabilized by the encroaching gravitational field of its colossal neighbor. Astronomers, utilizing sophisticated computer simulations like the seminal work by T.J. Cox and Abraham Loeb, meticulously model these interactions. These simulations, driven by the principles of Newtonian gravity, demonstrate how the dark matter halos, by virtue of their immense mass and spatial extent, are the primary invisible hands guiding the overall trajectory and initial deformation of the merging galaxies. They confirm that the gravitational whispers are not just theoretical constructs, but the fundamental, initiating forces of this cosmic apocalypse. It's crucial to understand that dark matter, while mysterious, is not a shield. Its diffuse nature means that individual dark matter particles will simply pass through each other, much like ghosts passing through walls. However, their collective mass exerts an overwhelming gravitational force. As the two halos interpenetrate, the gravitational potential well of our local group deepens and warps. This warping effect is the true first contact, a gradual reshaping of the gravitational landscape that governs every star, planet, and speck of dust within both galaxies. This isn't just about Andromeda pulling the Milky Way. It's about the entire local cosmic environment being fundamentally altered, its gravitational contours redrawn by the arrival of a new, combined superstructure. The insidious nature of this initial phase lies in its invisibility to the unaided eye. We cannot see dark matter, nor can we feel the subtle changes in the gravitational field across millions of light-years. Yet, these unseen forces are already at work, writing the preamble to our galactic doom. The vast, sparse clouds of hydrogen gas that extend far beyond the visible spiral arms of both galaxies are among the first ordinary matter components to feel this encroaching gravitational distortion. These diffuse gas clouds, being far less gravitationally bound than the dense stellar disk, will begin to heat up, compress, and even trigger initial bursts of star formation at the very fringes of the merging halos. These faint, distant signals might be the earliest detectable astrophysical markers of the interpenetration of the dark matter halos. The very concept of a galaxy, as a distinct, self-contained entity, begins to blur at these immense distances. What we perceive as the edge of the Milky Way is merely the point where its luminous matter thins out. Gravitationally, its influence extends much further, and it is at these extended, invisible boundaries that the Andromeda collision truly commences. This gravitational pre-contact is the slow, deliberate setting of the stage for a drama that will unfold over billions of years. It's a reminder that the universe operates on timescales and scales that dwarf human comprehension, where events that seem impossibly distant are already locked into an inexorable gravitational fate. This initial, subtle dance of dark matter halos underscores the existential dread of the collision. It highlights that the forces driving this cosmic apocalypse are not just external, dramatic impacts, but pervasive, invisible influences that began their work long before humanity even existed. Our current position, seemingly stable and secure, is already within the gravitational shadow of this impending doom. The fate of our solar system, whether it's gently nudged or violently flung, is being determined by these unseen hands, these gravitational whispers that are now growing steadily into an undeniable roar. The die is cast. The first inexorable steps of the galactic waltz are already being taken, orchestrated by the vast unseen masses of dark matter that dominate our cosmic neighbourhood. The initial gravitational whispers between Andromeda and the Milky Way's dark matter halos might seem like a distant abstract phenomenon, far removed from our immediate stellar neighbourhood. This leads to one of the most persistent and understandable misconceptions about galaxy collisions: the terrifying image of stars violently smashing into each other, planetary systems exploding in a cataclysm of fire and debris. But the truth, while equally catastrophic for the stability of our home, is far more subtle: a ghostly embrace where individual stars almost never touch, yet the very fabric of our galactic existence is irrevocably torn apart. To comprehend this paradox, we must first truly grasp the incomprehensible emptiness of space. Imagine our Sun, a magnificent star, as a grain of sand. On that scale, the nearest star, Proxima Centauri, would be another grain of sand located not miles away, but hundreds, even thousands of miles distant. Now, consider the Milky Way galaxy, a colossal disk containing hundreds of billions of such grains of sand. Even packed together in their spiral arms, the average distance between stars is so immense, light years, not light minutes, that the galaxy is overwhelmingly empty space. It is a vast, ethereal vacuum, punctuated by incredibly distant solitary points of light. When the Milky Way and Andromeda collide, it is not like two swarms of bees flying into each other, where every bee is guaranteed to hit another. Instead, it is more akin to two wisps of smoke passing through one another. The individual stars, including our Sun, are so widely spaced that the probability of a direct stellar impact is infinitesimally small, practically zero. For a star like our Sun, the chances of striking another star during the entire merger process are lower than winning the lottery multiple times in a row. It is a cosmic near miss for almost every individual star. So, if stars won't collide, why is this an impending apocalypse for our home? The answer lies in gravity, the invisible, pervasive force that governs the entire universe. While individual stars are unlikely to crash, the galaxies themselves, with their immense collective mass of billions of stars, vast reservoirs of gas and dust, and colossal dark matter halos, will most certainly collide. This is a collision of gravitational fields, a monumental wrestling match where the immense combined gravity of Andromeda and the Milky Way will utterly dominate and reshape everything within their spheres of influence. Picture a calm, orderly celestial dance, where each star follows a predictable, elegant orbit around its galactic centre. Now, introduce a gravitational sledgehammer, the immense mass of an entire invading galaxy. As Andromeda's gravitational field interpenetrates and merges with our own, this delicate equilibrium will be shattered. Stars that once followed stable circular paths will suddenly find themselves yanked, nudged, and accelerated by wildly fluctuating gravitational forces. Their orbits will become chaotic, stretched, and often violently redirected, like marbles bouncing uncontrollably within a rapidly shaking box. This isn't a direct collision, but a brutal gravitational ballet of disruption and displacement. The most profound and immediate impact of this gravitational chaos will not be on individual stars colliding, but on the delicate structures that bind gas and dust within galaxies. Unlike stars, which are dense, compact objects, galactic gas and dust clouds are diffuse and expansive. When these immense clouds, often millions of times the mass of our Sun, encounter each other at high relative velocities, they will collide. This is where the true fireworks of a galactic merger occur. The shock waves from these collisions will compress the gas and dust, triggering furious, widespread bursts of star formation. What appears as dazzling nurseries of new stars in astronomical images is, in reality, a chaotic, violent process, consuming vast amounts of interstellar material in a stellar birth frenzy. These bursts of star formation, while beautiful from a cosmic distance, represent an enormous expenditure of a galaxy's precious raw material. They are also incredibly energetic, with newly formed massive stars burning brightly and dying quickly in supernovae, blasting out powerful stellar winds and radiation. This intense activity can heat and expel gas from the nascent galaxy, influencing its future evolution, but for existing stable star systems like our own, it means navigating a radically transformed and violent environment. Our quiet, stable corner of the Milky Way, shielded for billions of years from such widespread chaotic events, will be engulfed in this maelstrom. Furthermore, at the very heart of both the Milky Way and Andromeda lie supermassive black holes, Sagittarius air in our galaxy, and a significantly larger counterpart in Andromeda. While these behemoths are currently millions of light years apart, the galactic collision ensures their eventual, inescapable union. As the galaxies merge, these colossal black holes will sink towards the centre of the newly forming Milkomeda. Their journey will be a gravitational death spiral, a titanic dance that will violently stir the central regions of the combined galaxy, flinging stars outwards like cosmic slingshots. Eventually, over hundreds of millions, possibly billions of years, they will merge in one of the most powerful events in the universe, emitting gravitational waves that ripple across space-time. This, a collision of space-time itself, represents a true cataclysm, but again, not a collision of individual stars. This understanding clarifies the true nature of the apocalyptic threat. While our Sun is safe from a direct stellar impact, its orbital path, the very foundation of our solar system's stability, will be profoundly imperiled. Imagine our solar system as a tiny boat on a vast, serene lake. The approaching Andromeda Galaxy is not another boat that will directly crash into us. Instead, it's a colossal, unseen tsunami generated far away, whose immense gravitational waves will relentlessly toss and turn our boat, threatening to capsize it or drag it far out to sea. The familiar, consistent gravitational pull from the Milky Way's centre will be superseded by the chaotic, unpredictable pulls and pushes from the merging galactic core, and the countless stars and dark matter clumps of Andromeda. The critical consequence for our blue planet isn't a fiery explosion from a stellar impact, but the slow, agonizing prospect of being ejected from the habitable zone of our Sun, or even from the nascent Milkomeda Galaxy itself. As the Sun's orbit becomes erratic, it could be flung too close to the galactic core, exposing Earth to sterilizing radiation and intense tidal forces. Alternatively, it could be ejected far into the outer reaches of the new galaxy, or worse, into the icy, intergalactic void between galaxies, a realm of perpetual darkness and absolute cold. In either scenario, the conditions for life on Earth would become untenable, leading to a slow, certain demise of our home, not through a sudden impact but through a gradual, unyielding environmental shift. This ghostly embrace is thus far more insidious than a direct collision. It is a slow, methodical dismantling of cosmic order. The very structure of our galaxy, the delicate balance that has nurtured life for billions of years, will be utterly dissolved. The once familiar constellations will twist and contort, stars will be scattered, and the Milky Way as we know it will cease to exist. The looming dread is not of a sudden, fiery death, but of a prolonged, agonizing dismemberment, a gravitational chaos that will ultimately render our corner of the universe unrecognizable and uninhabitable. The universe, in its elegant indifference, is orchestrating not a demolition derby, but a cosmic waltz of destruction and rebirth, with our home caught helplessly in its terrifying, graceful steps. If the ghostly embrace of dark matter halos represents the initial silent command for our galaxies to merge, then the next devastating phase is the explicit act of dismemberment, a slow, agonizing unraveling orchestrated by relentless cosmic forces. This is the Milky Way's slow death, not by impact, but by the insidious, pervasive grip of tidal forces that will tear apart its majestic spiral form, stripping away its elegance long before Andromeda truly becomes one with us. This gravitational violence, though slow, is utterly inevitable, and it begins hundreds of millions of years before the final dramatic merger. To understand this galactic tearing, we must delve into the concept of tidal forces. We experience them subtly on Earth every day. The Moon's gravity pulling more strongly on the side of Earth facing it, and less strongly on the far side, creating the familiar bulges of our ocean tides. But scale this phenomenon up to 2 colossal galaxies, each containing hundreds of billions of suns and dark matter halos stretching for light years, and the bulges become cataclysmic distortions. A tidal force is essentially a differential gravitational pull. One massive object pulls harder on the nearer side of another object than on its farther side, stretching it, distorting its shape and, if strong enough, tearing it apart. As Andromeda draws closer, its immense gravity will begin to exert precisely this differential pull on the Milky Way. The side of our galaxy facing Andromeda will be tugged with greater intensity than the side furthest away. This immense, unequal force will begin to stretch and distort our galactic disk, like taffy being pulled by an unseen hand. The elegant, tightly wound spiral arms of the Milky Way, which have remained stable for billions of years, are not rigid structures. They are delicate assemblages of stars, gas and dust, held together by a finely tuned gravitational balance. Andromeda's encroaching field will shatter this balance, elongating and warping these arms into grotesque, unfamiliar shapes. The first components to succumb to this relentless stretching will be the least gravitationally bound, the vast, diffuse clouds of interstellar gas and dust that populate the outer spiral arms. These ethereal nurseries of future stars, far from the stabilizing influence of the galactic core, will be easily pulled away. As the tidal forces rip through them, these clouds will be compressed and shocked, triggering frenzied bursts of star formation. What would appear to distant observers as magnificent nebulae birthing new suns is, in fact, a symptom of galactic trauma, a violent outpouring of stellar creation fueled by the destruction of pre-existing order. These newly formed stars will be short-lived, brilliant beacons in a dying galactic structure, signaling the beginning of the end. Beyond the initial gas and dust, the stars themselves, though not directly colliding, will be subject to this intense gravitational torment. Stars within the Milky Way's spiral arms currently follow relatively stable, near-circular orbits around the galactic center. But as Andromeda's gravity distorts the overall gravitational field, these orbits will become drastically elongated and perturbed. Imagine a celestial pinball machine, where billions of stars are suddenly knocked off their stable paths, sent careening into new, unpredictable trajectories. Some will be flung outward, forming immense tidal tails, long arcing streams of stars, gas and dust ripped from the main body of the Milky Way, stretching for hundreds of thousands of light years into the intergalactic void. This phenomenon of tidal stripping is a common sight in the cosmic tapestry, witnessed in countless images of merging galaxies across the universe. These observations serve as chilling previews of our own future, showing galaxies with long ethereal streamers of stars pulled away from their main bodies, like strands of hair trailing from a dancer in motion. For the Milky Way, this means our familiar, comforting spiral structure will slowly, agonizingly, be unraveled. The iconic image of our galaxy, a cornerstone of human understanding of our place in the cosmos, will be erased, replaced by a chaotic, deformed mass of stellar debris. The initial first pass of Andromeda, occurring perhaps 4.5 billion years from now, will be a particularly violent gravitational interaction. The two galaxies will not immediately merge into a single entity. Instead, they will swing past each other. Like two colossal ships passing in a narrow channel, their gravitational wakes creating immense havoc. This first close encounter will exert the most intense tidal forces, tearing apart the delicate outer structures of both galaxies, forming those vast tidal tails and reshaping their internal dynamics. Our Sun, currently nestled in a quiet region of the Orion Arm, will experience the full brunt of this gravitational upheaval, its stable orbit threatened by the sudden overwhelming influence of an entire invading galaxy. The Milky Way's disk, where most of its stars, gas and dust reside, is relatively thin. This makes it particularly vulnerable to tidal disruption from a massive approaching object. The differential gravitational pull can easily puff up the disk, moving stars out of their planar orbits and into more eccentric, chaotic paths. Over the course of the merger, the once flat organized disk will effectively be destroyed, its components scattered into a more spherical or elliptical distribution, completely unrecognizable from the spiral galaxy we call home today. This transformation is not quick, a slow-motion cosmic dance of dismemberment. The existential dread inherent in this process lies in the understanding that our galaxy, our cosmic home, is not invulnerable. It is a dynamic, evolving entity subject to the same colossal forces that shape all structures in the universe. The slow, but certain, destruction of the Milky Way's familiar form is a stark reminder of cosmic impermanence. The stars we see in our sky, once part of a cohesive, elegant structure, will become wanderers, their paths dictated by the chaotic, merging gravitational fields. This isn't just a scientific prediction. It's a cosmic obituary for the Milky Way, a testament to the fact that even the grandest structures eventually yield to the relentless, transformative power of gravity. Our home is already on the path to an irreversible slow-motion dismantling, its fate sealed billions of years ago. While the Milky Way endures its slow, agonizing dismemberment by Andromeda's inexorable tidal forces, the implications for our own tiny corner of the cosmos, our solar system, are perhaps the most chilling. Our Sun, the anchor of our existence, a beacon of stability for nearly 5 billion years, is destined for a reckoning, a chaotic gravitational dance that could shatter the delicate equilibrium maintaining life on Earth. This is not a distant, abstract phenomenon, but a direct threat to our planetary home, a slow-motion cosmic upheaval that will utterly redefine our place in the universe. For eons, our Sun has traced a predictable, nearly circular orbit around the galactic centre, completing a full revolution roughly every 220 million years. This orbital stability is paramount. It keeps us at a relatively constant distance from the Milky Way's energetic and often dangerous core, and it dictates the calm, ordered motion of all the planets, asteroids and comets in our solar system. This delicate balance, a cosmic clockwork, has allowed life on Earth to evolve and flourish without catastrophic interruption from larger galactic forces, but the impending merger with Andromeda will shatter this ancient rhythm, plunging our Sun into a maelstrom of unpredictable gravitational forces. As Andromeda makes its initial destructive passes, its immense gravitational field will dramatically warp the overall gravitational potential of our local galactic neighbourhood. Imagine our Sun not as an isolated entity, but as one particle in a colossal turbulent fluid. When two immense currents collide, individual particles are buffeted and redirected with immense force. The Milky Way's gravitational pull will be overshadowed, then superseded by the combined chaotic gravitational fields of both galaxies and their gargantuan dark matter halos. Our Sun's once stable orbit will become a frantic, erratic trajectory, pulled first this way, then that, by the competing gravitational attractions of billions of stars, vast gas clouds, and the supermassive black holes at the merging galactic cores. This isn't a gentle nudge. This is the equivalent of a cosmic slingshot or multiple slingshots, flinging our star and its planetary entourage through unfamiliar and potentially hostile regions of the nascent Andromeda Galaxy. Numerical simulations of galactic mergers consistently show that while direct stellar collisions are rare, significant orbital perturbations are the norm. Our Sun could be accelerated to extreme velocities, its path bent into a wildly eccentric ellipse, or even worse, it could be flung out of its stable position entirely, like a stone from a giant's hand. One terrifying possibility is that our solar system could be flung much closer to the heart of the merging galaxies. The galactic centre, even of a newly formed elliptical galaxy, is a dangerous place. It harbours a supermassive black hole, an intense concentration of stars and regions of active star formation that are incredibly bright and energetic. exposure to such a harsh environment would bombard Earth with lethal levels of X-rays, gamma rays, and other high-energy radiation. This radiation, far exceeding our planet's natural shielding, would sterilize the surface, stripping away our atmosphere and eradicating any hope of continued life. A fiery doom delivered not by our sun, but by the violence of a galactic core. Alternatively, and perhaps even more chillingly, the gravitational chaos could eject our entire solar system, intact but utterly displaced, into the vast, cold emptiness of the intergalactic void. Picture our sun, now a solitary star drifting aimlessly through the frigid darkness between galaxies. An orphan cast out from its cosmic home. This is a fate far more desolate than any fiery destruction. In the intergalactic void, light from other galaxies would be incredibly faint, mere smudges in a sky dominated by blackness. The ambient temperature would plummet to near absolute zero, and the resources that nourish future star formation would be non-existent. Our sun would continue to burn for billions of years, but any planets orbiting it would be bathed in an eternal profound cold, their surfaces frozen solid, their atmospheres stripped away by the vacuum, devoid of any external warmth or light beyond their own star. The consequences for Earth, cradled within this chaotic system, are profound. Our world's habitability depends on a delicate balance of conditions, primarily our distance from the sun, which keeps liquid water flowing on our surface. If our sun's orbit is drastically altered, if it's flung further from the dense galactic plane or into a region with different stellar densities, the gravitational environment of the entire solar system would destabilize. The orbits of Jupiter, Saturn, and other gas giants, which currently act as gravitational shields and shepherds for the inner planets, could be perturbed. This could lead to a cascade of orbital instabilities, potentially flinging Earth itself into the sun or ejecting it completely from the solar system to wander alone in the dark. The timescale for this solar reckoning is immense, yet it's precisely this drawn-out nature that makes it so terrifying. The gravitational disruptions won't happen overnight. Instead, our sun's orbit will slowly, agonizingly, become more erratic over hundreds of millions of years. Generations upon generations of any hypothetical future inhabitants of Earth would witness a sky increasingly alien, a sun no longer predictable, and a future increasingly uncertain. The slow, creeping dread of impending cosmic displacement would be a constant, inescapable reality. This is the ultimate act of cosmic homelessness. Our sun, once a stable anchor within the Milky Way's gravitational embrace, will become a pawn in a game of galactic billiards, its fate determined by the overwhelming gravitational forces of a merging universe. The very concept of a habitable zone becomes meaningless when the star it depends on is ripped from its stable environment. Our home, so lovingly nurtured for billions of years, faces not a swift sudden end, but a slow, inexorable journey towards an environment utterly hostile to life. The sun's reckoning is a chilling reminder of our cosmic vulnerability. Most fundamental constants of our existence are subject to the grand, indifferent, and destructive ballet of merging galaxies. Our home is truly at the mercy of forces beyond our comprehension, forces that are now undeniably converging. The sun's impending reckoning, a cosmic game of billiards played with unimaginable masses, ushers in the profound existential threat to Earth's most precious asset, its habitability. Our world, for billions of years, has resided within a narrow life-sustaining band around our star, a region scientists call the habitable zone, or more evocatively the Goldilocks zone. Here, temperatures are neither too hot nor too cold, allowing liquid water to persist on a planetary surface, the fundamental solvent, the very crucible for life as we know it. But as our sun is flung into chaos by the merging galaxies, this delicate cosmic balance will shatter, condemning Earth to either a slow, agonizing freeze or a searing, fiery oblivion. The core of this impending doom lies in the potential for extreme alterations to Earth's orbital path around the sun. Currently, our planet traces a nearly circular orbit, maintaining a remarkably consistent distance from our star. This stability is the bedrock of our climate, our seasons, and indeed, our very existence. However, when the sun's galactic orbit becomes erratic, pulled and pushed by the combined turbulent gravitational fields of the Milky Way and Andromeda, This external chaos will inevitably propagate inwards, destabilizing the entire solar system. The subtle gravitational tugs from passing stars, gas clouds, or even rogue dark matter clumps once negligible will amplify dramatically. Our planetary system, currently a marvel of gravitational precision, could become a cosmic pinball machine. One terrifying outcome of this gravitational turbulence is the ejection of our solar system, or specifically Earth's orbit, further out from the Sun. Imagine our planet's path gradually stretching, elongating into a vast eccentric ellipse. For much of its new elongated year, Earth would be plunged into an era of profound, crushing cold, receiving only a fraction of the solar energy it currently enjoys. The consequences would be slow, yet utterly devastating. Our oceans, once vibrant with life, would progressively freeze, first at the poles, then relentlessly creeping towards the equator, locking vast quantities of water into impenetrable glaciers. The planet would transform into a stark blue-white marble, cloaked in an eternal winter. As the global temperature plummets, our delicate atmosphere would begin to condense, particularly carbon dioxide, which plays a crucial role in trapping heat. This would trigger a runaway cooling effect, further accelerating the planetary deep freeze. The vibrant ecosystems that depend on liquid water and a temperate climate would wither and die, entombed beneath miles of ice. Any remaining life might retreat to the planet's core, clinging to geothermal vents, a faint echo of the once teeming biosphere. But for the surface, for the world we recognize, it would be a slow, agonizing death by ice, a prolonged descent into an uninhabitable, frozen wasteland. This isn't a swift, merciful end, but a drawn-out, inescapable decline into cosmic desolation, stretching over millennia, perhaps even millions of years, as our orbital path slowly, inexorably, carries us further from the Sun's life-giving embrace. Conversely, the gravitational reshuffling could just as easily fling Earth into a much tighter, more compressed orbit around the Sun. Imagine our planet spiralling inwards, drawn closer and closer to the intense heat and radiation of our star. The delicate balance that maintains our liquid oceans would quickly be overwhelmed. Surface temperatures would skyrocket, causing the oceans to boil away, first slowly, then with increasing ferocity, sending vast plumes of superheated steam into the atmosphere. This moisture, a potent greenhouse gas, would trap even more heat, creating a runaway greenhouse effect reminiscent of Venus, but far more extreme. The once blue skies would turn a suffocating, fiery red, heavy with steam and carbon dioxide. The land masses would bake under a relentless, magnified solar glare, eventually turning to molten rock. The very crust of the planet might crack and buckle, unleashing volcanic fury on an unprecedented scale. Any form of life, from the hardiest extremophile bacteria to the most complex organisms, would be incinerated, reduced to elemental components by the infernal heat. Our vibrant, living world would become a barren, suffocating inferno, its surface a hellish landscape of molten rock and superheated gases. This too would be a slow destruction, a gradual escalation of heat, an agonizing demise unfolding over centuries as the planet's orbit constricted. Furthermore, the general gravitational upheaval across the solar system poses additional, more immediate threats. The orbits of the gas giants, Jupiter, Saturn, Uranus, and Neptune, which currently act as celestial shepherds, guiding asteroids and comets safely away from the inner solar system, could be severely disrupted. A perturbed Jupiter, for instance, could become a gravitational rogue, its immense pull flinging icy comets from the Oort cloud and rocky asteroids from the Kuiper belt directly into the path of the inner planets, including Earth. We could face a terrifying increase in catastrophic impact events, adding sudden, violent punctuation marks to our planet's slow, agonizing decline, or even delivering the final crushing blow. The existential dread of this scenario is amplified by its inevitability and its protracted nature. For hypothetical future generations on Earth, knowing that their world is slowly but surely succumbing to either a creeping cold or an escalating heat would be an unbearable burden. The very ground beneath their feet, the air they breathe, the water that sustains them, all would become harbingers of a slow, certain destruction. The planet itself, once a symbol of vibrant life, would slowly transform into a tomb. This is not the natural, graceful end of Earth, which would eventually be consumed when our own sun expands into a red giant in roughly 5 billion years. This is a premature, imposed apocalypse, forced upon us by the grand, indifferent ballet of merging galaxies, ensuring that our home faces a slow, agonizing death long before its star intends it. The habitable zone, Earth's cosmic cradle, is destined to become its grave, not with a sudden cataclysm, but with a prolonged, inescapable unravelling of its life-giving equilibrium. While the previous discussion centred on the slow, agonising destruction of Earth's habitability within a chaotic galactic core, there exists an even more chilling prospect for our solar system: complete and utter galactic exile. The relentless gravitational maelstrom of the Milky Way-Andromeda merger holds the terrifying potential to violently eject our entire solar system from the newly forming Andromeda Galaxy, casting our Sun, Earth, and all its planetary companions adrift into the boundless, icy desolation of the intergalactic void. This is the ultimate cosmic homelessness, a fate far more profound than mere orbital perturbation, a slow, certain abandonment to an endless dark. The mechanism for such a dire outcome lies in the ferocious gravitational dynamics of merging galaxies. As the two colossal systems, each containing hundreds of billions of stars and vast reservoirs of dark matter, hurtle through each other, their collective gravitational fields become wildly erratic and unpredictable. Imagine a cosmic billiard table, but instead of just two balls, there are hundreds of billions, all exerting complex, constantly shifting gravitational pulls on one another. During the chaotic passes and recoils, a star or an entire star system, like our own, can experience what astronomers call a gravitational slingshot effect. If our Sun encounters a sufficiently massive star, or, more likely, a denser clump of dark matter from Andromeda, its trajectory could be altered so dramatically that it gains enough velocity to escape the gravitational clutches of the nascent galaxy entirely. Consider the immense energy required for such an ejection. Our Sun is currently gravitationally bound to the Milky Way, orbiting its centre at a comfortable 220 km per second. To escape the combined gravitational pull of Andromeda would require a substantial increase in this velocity, a cosmic kick that propels it beyond the escape velocity of the new mega-galaxy. While the probability of any single star being ejected is relatively small, given the sheer number of stars involved in a galactic merger, it is a statistically significant outcome for a considerable fraction of stellar systems. Our solar system, being one among hundreds of billions, is not immune to this cosmic roulette. The closer our Sun is to the violent central regions where the two galaxies' cores are merging, the higher the chances of such a catastrophic gravitational interaction. Once ejected, our Sun would embark on a solitary, unending journey through the intergalactic void. Picture a lone, flickering candle cast out into an infinite, cavernous darkness. This is a realm of unimaginable emptiness, far removed from the glittering stellar nurseries and vibrant gas clouds of a galaxy. The average density of matter in the intergalactic medium is incredibly low, perhaps a single atom per cubic meter. There are no other stars to illuminate the darkness, no nebulae to paint the sky with colour, no other galaxies close enough to appear as more than faint, distant smudges. The sky, as seen from an ejected Earth, would be a canvas of profound, eternal black, punctuated only by the unwavering pinprick of our Sun and the other planets, now rendered utterly alone. The immediate consequence for Earth, still orbiting its exiled Sun, would be a slow descent into unimaginable cold. While, providing its familiar warmth and light, the ambient temperature of space in the intergalactic void hovers just above absolute zero, a frigid 2.7 Kelvin, the faint afterglow of the Big Bang itself. Within a galaxy, the diffuse interstellar medium and radiation from countless stars contribute to a slightly warmer environment. Outside, there is no such cushioning. Our planet's fragile atmosphere, currently shielded by the Sun's gravity and the galaxy's magnetic fields, would be slowly eroded by the harsh, unfiltered cosmic rays and the sheer vacuum. What warmth it could retain from the Sun would rapidly dissipate into the infinite cold. The existential dread of this galactic exile is profound. It represents the ultimate cosmic homelessness. For hypothetical future generations on Earth, the very notion of a galaxy would transform from a tangible home into a distant, unattainable memory. Our species, intrinsically linked to the concept of a solar system within a galaxy, would become cosmic wanderers, a rogue civilization adrift in an endless, meaningless expanse. The rich tapestry of the night sky, once a source of wonder and navigation, would become a desolate, featureless void, offering no comfort, no direction, no connection to a larger cosmic community. This is not just the end of Earth's habitability, it is the end of our galactic identity. The scale of this displacement is staggering. Our Milky Way is roughly 100,000 light-years across. The distance between galaxies in the local group is typically millions of light-years. To be ejected means traversing these colossal, empty gulfs, a journey that would take billions of years, potentially even longer than the remaining lifespan of our Sun. Our solar system would become a timeless ghost ship sailing through an ocean of nothingness, its inhabitants, if any survived, forever cut off from the dynamic star-forming regions that give rise to planets and the potential for life, even if humanity, through advanced technology, managed to adapt to such an existence, perhaps by burrowing deep underground, utilizing geothermal energy, or building vast space habitats. The psychological toll would be immense. The sense of isolation would be absolute, knowing that every other star, every other planet, every other potential form of life resides in a galaxy impossibly far away, a shimmering island of light forever beyond reach. This isn't just a physical displacement, it's a spiritual and philosophical eviction, forcing us to redefine what it means to belong to the universe. This terrifying possibility transforms the slow, but certain, destruction of our home into something even more stark. It is not just the destruction of Earth's conditions for life, but the destruction of our galactic context. Our home is not merely a planet, it is a system of planets orbiting a star, nestled within a spiral arm of a magnificent galaxy. To be ripped from that embrace is to lose our fundamental cosmic identity, to become an orphan in the vast, indifferent expanse. The intergalactic void is a cosmic graveyard, a place where light and life are rare anomalies. To be cast into it is to be condemned to an eternity of cold, dark, and profound loneliness, a desolate end to our tenure in the vibrant, star-studded tapestry of the Milky Way. Our solar system, once a part of a grand design, would become a cosmic outcast, forever adrift. While the fate of our solar system hangs in the balance, facing either orbital upheaval or outright galactic exile, the grander narrative of the Milky Way and Andromeda culminates in a spectacle of cosmic creation born from immense destruction. This is the story of Milkomeda's turbulent genesis, the violent birth of a monstrous new galaxy that will rise from the shattered remnants of two spiral titans. For hundreds of millions, possibly billions of years, the merging galaxies will be a maelstrom of chaos, before eventually settling into a new, stable, and utterly unfamiliar elliptical form. The process of galactic merging is not a single, instantaneous event, but a protracted, drawn-out affair involving multiple passes and recoils. After the initial gravitational embrace and the first destructive tidal stripping, the Milky Way and Andromeda will likely overshoot each other, swinging past one another due to their immense momentum. This first close encounter, moment of incredible gravitational violence, tearing apart gas clouds, distorting spiral arms, and flinging stars into chaotic new trajectories. Both galaxies will emerge from this pass as severely disfigured, unrecognizable versions of their former selves, their elegant spirals replaced by elongated, messy structures and vast tidal tails streaming into the void. Following this first pass, the now disfigured galaxies will be gravitationally bound to each other even more tightly. Their mutual attraction will inevitably draw them back together for a second, even more profound interaction. This gravitational dance will repeat, gradually bringing the two galactic cores closer and closer. With each pass, more gas, dust, and stars will be stripped away, their kinetic energy converted into heat and outward motion, further dissolving the original structures. This is a cosmic grinding, a slow, inexorable process of dissolution, where the distinct identities of the Milky Way and Andromeda are slowly but surely erased. Crucially, these violent gravitational interactions will trigger an unprecedented era of star formation. The immense diffuse clouds of hydrogen gas and dust that were once stable within the individual galaxies will be violently compressed by shock waves generated during the close passes. When interstellar gas clouds collide and are squeezed beyond a critical density, they collapse under their own gravity, igniting vast numbers of new stars. Milkomeda will thus experience a starburst phase, a spectacular, furious outpouring of stellar creation. From a distance, the merging region would blaze with the light of millions of newborn stars, outshining any previous era of star formation in either galaxy. While visually stunning, this starburst phase is also incredibly energetic and potentially destructive. Massive, newly formed stars burn through their fuel at a furious pace, living short, brilliant lives before exploding as supernovae. These colossal stellar deaths blast out powerful shockwaves, intense radiation, and heavy elements, further stirring the remaining gas and dust. This, preventing further star formation in the long term, but in the short term, it creates an incredibly dynamic and hazardous environment. Any existing planetary systems caught within these starburst regions would be subjected to intense radiation bombardment, a stark contrast to the relative calm of our Sun's current galactic neighbourhood. At the heart of this turbulent genesis lies the inevitable merger of the two supermassive black holes, Sagittarius. In the Milky Way, and Andromeda's even larger central black hole will embark on a gravitational death spiral. As the galaxies draw closer, these black holes will sink towards the common centre of the new system. They will orbit each other for hundreds of millions of years, slowly radiating away orbital energy through gravitational waves, gradually drawing nearer. This binary supermassive black hole system, nascent Milkomeda, further disrupting stellar orbits and flinging stars outwards. Eventually, they will coalesce into a single, colossal supermassive black hole, an event that would unleash an enormous burst of gravitational waves and potentially powerful jets of radiation, marking the final, definitive act of the merger. After hundreds of millions or even a few billion years of this chaotic dance of destruction and creation, the newly formed galaxy will finally settle. The kinetic energy of the merging components will have dissipated, and the stars, gas, and dark matter will arrange themselves into a new, more stable configuration. The result will not be another spiral galaxy. The violent interactions, the destruction of the thin, rotating disks, and the randomizing of stellar orbits will transform the two spirals into a single, much larger elliptical galaxy. Elliptical galaxies are characterized by their smooth, featureless, often spherical or football-shaped appearance. They typically contain older, redder stars and very little gas and dust, as most of it would have been consumed in the starburst phase or ejected during the chaotic merger. Milkomeda, or Milkomedromeda, as it might eventually be known, will be a colossal, majestic elliptical galaxy, a gravitational monument to the cosmic collision that forged it. Its central supermassive black hole will be a gargantuan entity, holding sway over a vast, stable system of stars that orbit in a more random, less organised fashion than in a spiral. For any hypothetical observers remaining within this new elliptical galaxy, the night sky would be profoundly different. The familiar band of the Milky Way would be gone, replaced by a diffuse luminous glow spread across the entire sky. Instead of distinct spiral arms, there would be a more uniform distribution of stars with a greater density towards the centre. While the extreme starburst phase would have faded, the core of Milkomeda would still be a region of incredible stellar density, a far cry from our Sun's current relatively sparse neighbourhood. The birth of Milkomeda is a testament to the universe's capacity for renewal through violence. It is an act of cosmic alchemy, transforming two beautiful, distinct spiral galaxies into a single, massive, and entirely new entity. This transformation underscores the dynamic nature of the cosmos, where even seemingly permanent structures like galaxies are ephemeral, destined for change. While the process spells the slow, but certain, destruction of our current galactic home and potentially our solar system's stability, it also marks the creation of a new, colossal structure, a future monument to this ultimate cosmic apocalypse, forged in fire and gravitational chaos. While scientists meticulously model the gravitational mechanics of Milkomeda's birth, what truly resonates with the human experience is the transformation of the night sky itself. If hypothetical future generations were to survive Earth's orbital upheavals and remain anchored to our Sun, they would be privileged, or perhaps cursed, to witness a celestial drama of unparalleled grandeur and terrifying beauty. This is the Andromeda sky, a stellar apocalypse unfolding over millions of years, a slow-motion cosmic ballet that would redefine humanity's perception of its place in the universe. The familiar, comforting constellations would warp and dissolve, giving way to an alien landscape of unparalleled brilliance and chaos, a constant, visual reminder of our home's slow, certain destruction. Today, Andromeda is a faint, fuzzy smudge in our northern sky, barely visible to the naked eye under ideal conditions. It is a distant, serene spiral, a ghostly island universe quietly awaiting its destiny. But in approximately 4 billion years, this distant blur will begin its ascent to celestial dominance. As Andromeda's dark matter halo begins its deep interpenetration with our own, and its visible disk draws closer, its apparent size in the night sky will slowly grow. Over millions of years, it would expand from a faint patch of light into a shimmering oval, then into a distinct, immense spiral, dwarfing the moon in angular size. This would be the first tangible sign of the impending doom, a colossal, ever-growing spectre dominating the celestial sphere. Around 4.5 billion years from now, the two galaxies will make their first close pass. From Earth's perspective, if it still clung to a habitable orbit, the night sky would transform into an unimaginable spectacle. Andromeda, by then a colossal presence, would fill a significant portion of the sky, its spiral arms twisting and intermingling with those of the Milky Way. This isn't a gentle merge, it would be a violent gravitational interaction, visually translating into long ethereal streamers of stars and gas being pulled from both galaxies, forming immense tidal tails that would stretch across the heavens. Imagine celestial fireworks on an apocalyptic scale, as gas clouds collide and ignite new stars, turning vast regions of the sky into brilliant, transient starburst nurseries. The iconic Milky Way band, the luminous river of stars that bisects our current night sky, would begin to distort and fray. Its once familiar shape would be stretched and warped, its dense concentrations of stars scattering like dust motes in a cosmic wind. New, brilliant clusters of stars would flare into existence as gas clouds, shocked by the collision, collapsed under their own gravity. The constellations, those ancient patterns that have guided humanity for millennia, would become unrecognizable, their constituent stars flung into new positions, their relationships to each other irrevocably severed. The comfort of familiarity would be replaced by the terror of a constantly changing, ever more chaotic firmament. Following this first pass, the galaxies would recoil, pulled apart by their remaining momentum, but forever bound by their overwhelming mutual gravity. During this period, lasting for hundreds of millions of years, the sky would again change, perhaps with Andromeda receding slightly, only to reappear larger and more menacing as the galaxies began their next, closer approach. Each pass would further distort the structures, painting an increasingly chaotic and fragmented picture across the celestial dome. The sky would be a living, breathing canvas of gravitational violence, a dynamic panorama of cosmic destruction and rebirth. The ultimate final merger, occurring perhaps 6 billion years from now, would be the most profound transformation. The two galactic cores, with their supermassive black holes, would finally coalesce, and the remaining stars, gas and dark matter would settle into a new, stable form, a giant elliptical galaxy. From an Earth still orbiting its sun within this new entity, the sky would be utterly alien. The distinct spiral arms of both former galaxies would be gone, replaced by a smooth, diffuse glow of stars spread across the entire celestial sphere. The central region of this new Milkomeda elliptical galaxy would be incredibly dense, a blazing sphere of stars far brighter and more crowded than our current galactic neighbourhood. Imagine a sky where stars are so numerous and closely packed that the entire firmament glows, perhaps too brightly for true darkness to ever fall. Light pollution, on a cosmic scale, would be the new norm. The sheer density of stars in this new elliptical galaxy's core would create a perpetual twilight, altering any planetary climates and presenting a radically different environment for any life that endures. The spectacle would be breathtaking, undoubtedly, but it would also be a constant, stark reminder of the wholesale destruction of the Milky Way, the complete erasure of its former glory. The Andromeda sky, therefore, is not just an astronomical prediction. It is a profound existential narrative. It speaks to the impermanence of even the grandest cosmic structures and the deep fragility of our perceived stability. For any sentient beings witnessing this cosmic apocalypse from Earth, the experience would be a unique and terrifying confrontation with the dynamic, often destructive forces that sculpt the universe. The slow transformation of a familiar night sky into an alien, chaotic, then ultimately a newly ordered but utterly unrecognizable panorama serves as the most potent visual metaphor for the slow but certain destruction of our galactic home. It is a future written in the stars, a celestial masterpiece of creation through fire and gravitational chaos, reminding us that even the heavens are subject to the relentless march of cosmic time. The tapestry of human history is woven from moments, centuries, decades, years, each a precious thread in our collective memory. We measure our lives in heartbeats, our civilizations in millennia. Yet, the universe operates on an entirely different scale, a cosmic clock whose every tick represents an epoch, a geological age, or the lifespan of entire stars. And on this grand, indifferent cosmic clock, the hour hand is steadily advancing towards humanity's ultimate test. The colossal, inevitable collision of the Milky Way and Andromeda, an event set to unfold over billions of years. A slow-motion apocalypse that will utterly transform our galactic home. The initial gravitational encounter, the first disruptive pass, is predicted to occur in approximately 4.5 billion years. The full, irrevocable merger into a single colossal elliptical galaxy will take another 1 to 2 billion years beyond that, culminating around 6 to 7 billion years from now. To place this within a human comprehensible context, consider our Sun. It is currently halfway through its stable hydrogen-burning phase, with roughly metamorphosis into a bloated red giant, eventually consuming Earth. This chilling overlap in cosmic timetables means that the galactic collision with its profound disruptive effects will commence before our Sun naturally dies. This isn't a problem for a humanity long extinct from stellar evolution. Star is still vital, while Earth could theoretically still harbour intelligent life, forcing a confrontation with an existential threat of unimaginable scale and duration. Such immense timescales render the immediate fate of current humanity irrelevant. Our distant descendants, or perhaps entirely different species that inherit the Earth, would be the ones to witness the first tangible signs of the Andromeda approach. However, the very thought forces us to confront the profound question of resilience. If humanity were to endure, to achieve a multiplanetary or even interstellar civilization, how would it grapple with an impending, unstoppable cosmic transformation that promises the slow, certain destruction of its ancestral home? The notion of a galactic home would become a fleeting concept, replaced by an awareness of profound impermanence. The key to understanding the deep dread of this event lies in its protracted nature. This is not a sudden, merciful cataclysm, like a rogue asteroid impact or a nearby supernova, which would be over in an instant. Instead, the collision will be a drawn-out, agonizing process, a slow unraveling unfolding over hundreds of millions of years. Imagine generations upon generations, spanning a time frame 1,000 times longer than all of human recorded history, living under a sky that is visibly constantly changing. First, the Andromeda Galaxy would grow from a faint smudge to an immense dominating spiral, a relentless looming spectre. Then, its spiral arms would begin to intermingle with our own, forming vast, luminous tidal tails, igniting bursts of star formation that would paint the heavens with apocalyptic beauty. For those hypothetical future civilizations on Earth, or in our solar system, this would be a continuous, inescapable reminder of their impending displacement. The slow distortion of familiar constellations, the gradual erasure of the Milky Way's iconic band, the ceaseless reshuffling of stellar neighborhoods, all would serve as a cosmic clock ticking down to an unknown fate. The psychological impact of such a long-term, visible, and utterly unavoidable transformation is almost impossible to comprehend. It would fundamentally alter philosophy, art, religion, and the very concept of human permanence. The sky, once a symbol of eternity, would become a relentless harbinger of irreversible change. From a technological standpoint, the challenge would be unprecedented. Could a future humanity, armed with technologies we can only dream of, attempt to influence their destiny. Perhaps theories of stellar engineering, the ability to subtly nudge our sun's orbit, might be explored, though the energy required to counter the gravitational pull of two merging galaxies would be staggering, bordering on impossible. More plausibly, a long-term strategy of interstellar exodus might be considered. This wouldn't be a frantic escape, but a carefully planned, multi-generational migration to another galaxy, or to the quiet, stable regions of the intergalactic void, seeking refuge from the maelstrom. Such a venture would redefine humanity, transforming us into a truly nomadic, spacefaring species, a cosmic refugee fleet seeking a new, permanent home in an indifferent universe. However, even if humanity were to escape the direct chaos, the core of the dilemma remains. The Milky Way, the cradle of our existence, will cease to be. Its unique identity, its familiar stars, its specific cosmic address, will be irrevocably dissolved into the grander new entity of Milkomeda. This loss transcends the physical. It is a profound philosophical severing from our cosmic origins. We would become children of a new alien galaxy, forced to adapt to a vastly different stellar landscape and gravitational environment. The very concept of Terra, or Sol, as a fixed central point of reference, would be forever altered. The collision of the Milky Way and Andromeda serves as a humbling reminder of our cosmic insignificance, yet highlights the extraordinary resilience that might be required of any long-lived intelligence. The universe, in its majestic indifference, cares not for our timelines or our sentimental attachments to stellar arrangements. It operates on its own grand, inexorable schedule. This cosmic collision is not just an astronomical event, it is an ultimate evolutionary and civilizational challenge. It forces us to ponder whether humanity, given billions of years, can transcend its planetary and even galactic origins to become a species capable of enduring such colossal transformations. The timetable is set, the celestial bodies are in motion, and the gravitational forces are unstoppable. The Milky Way, our magnificent home, is destined to be unmade and remade, and our solar system is along for the ride. Whether we face a slow freeze, a fiery doom, or a lonely exile into the intergalactic void, the future of our home is one of certain destruction as we know it, followed by an agonizing transformation. The cosmic clock is ticking, not towards an end, but towards a profound, inescapable metamorphosis of everything we have ever understood about our place in the infinite cosmos. The dread is real, and it is billions of years in the making. We began this journey by confronting a cosmic truth both ancient and terrifying, the inevitable collision of our Milky Way with the colossal Andromeda Galaxy. We charted the inexorable approach, a celestial appointment spanning billions of years, confirmed by the unambiguous language of blueshift and the painstaking precision of Hubble's gaze. The initial gravitational whispers of dark matter halos have already begun to echo across the vast intergalactic gulf, setting in motion a chain of events that will culminate in the slow, yet certain, destruction of our home as we know it. The picture we have painted is not of shattering stars, but of a far more insidious gravitational apocalypse. While individual suns are too sparsely distributed to physically collide, the immense collective mass of two merging galaxies will wreak havoc on a scale almost impossible to conceive. It is a ghostly embrace where the very fabric of galactic order is torn asunder, a colossal wrestling match of gravitational fields that will reshape everything within their spheres of influence. The Milky Way's elegant spiral arms, once thought to be eternal features of our cosmic identity, are destined to be stretched, warped, and ultimately dissolved by the relentless pull of Andromeda's differential gravity. For our fragile blue marble, Earth, and its life-giving star, the stakes are nothing less than existential. Our Sun, a beacon of stability for 5 billion years, will be thrust into a maelstrom of chaotic gravitational forces. Its once predictable orbit around the galactic centre will become wildly erratic, a cosmic pinball ricocheting through the merging stellar densities. This profound disruption carries two terrifying fates for Earth: a slow, agonizing ejection from our Sun's habitable zone, condemning our world to either a creeping global freeze or a searing runaway incineration, or, even more chillingly, our entire solar system could be violently flung from the nascent Milkomeda Galaxy altogether, condemned to wander endlessly through the frigid, desolate darkness of the intergalactic void, an orphaned star system lost in an ocean of profound emptiness. In either scenario, the conditions for life would become untenable, leading to the slow, agonizing yet certain destruction of our home. Yet, from this colossal destruction, a new titan will emerge. From the shattered remnants of two magnificent spirals, a single, colossal elliptical galaxy will rise. Andromeda, born from fire and gravitational chaos, will eventually settle into a new, stable, and utterly unfamiliar form. This turbulent genesis, marked by spectacular starbursts and the ultimate merger of two supermassive black holes, is the universe's way of renewal, a testament to the continuous cycle of creation through profound transformation. The night sky, as seen by any hypothetical survivors on Earth, would be utterly alien, a luminous, diffuse glow replacing the familiar band of the Milky Way, a constant visual reminder of our lost galactic home. This cosmic timetable, aligning tragically with the remaining lifespan of our own sun, compels us to a profound philosophical reflection. We, as a species, cling to notions of permanence, of a stable home, of an unchanging sky. Yet, the universe offers no such guarantees. Our galaxy, the very cradle of our existence, is not an immutable sanctuary but a dynamic entity, subject to forces that dwarf our comprehension. The looming collision with Andromeda serves as the ultimate cosmic memento mori, a stark reminder that even the grandest structures are ephemeral, destined for change. The profound sense of existential dread inherent in this event is not merely about physical destruction, it is about the unravelling of our very definition of home. Is home a planet, a solar system, or the vast, intricate tapestry of a galaxy? When that larger home is utterly transformed, when the constellations that guided our ancestors are scattered into chaos, when our very cosmic address is erased, what does that do to our identity? It forces us to confront our fragility, our vulnerability, and the immense indifference of the universe to our existence. The slow, certain destruction of our home is not a sudden, merciful blow, but a drawn-out, agonizing process that will unfold over millions of years, a constant, inescapable reminder of our ultimate cosmic displacement. But perhaps, within this terror, lies a deeper lesson in awe and resilience. The universe is a canvas of both creation and destruction, a relentless sculptor of cosmic forms. Our capacity to even understand this impending apocalypse, to model its physics and predict its terrifying grandeur, elevates us beyond mere passive observers. It pushes us to ponder humanity's long-term aspirations. Can we, over billions of years, transcend our planetary origins, adapt to such colossal transformations, or even, perhaps, steer our destiny? Could future generations become truly galactic, embracing a nomadic existence? Or engineering a new stability amidst the chaos is a deep question posed to any intelligent life within them. It challenges our perception of stability, our desire for permanence, and our place in the cosmic narrative. It reminds us that our present calm is but a fleeting moment in a story spanning eons, a temporary reprieve before the universe's grand, indifferent ballet takes its course. The ultimate fate of our sun, our Earth, and perhaps humanity itself hangs in the balance of this gravitational tango, a testament to the universe's ceaseless, magnificent, and often terrifying transformation. The stars whisper not of an ending, but of an eternal beginning, a new cosmic dawn forged from the ashes of our galactic home. We are not just witnesses to this grand spectacle. We are, for now, inextricably part of its unfolding, a tiny blue speck in an unfolding cosmic apocalypse that is as beautiful as it is devastating.